Welcome everybody to today's HatchWorks AI Labs. For those that don't know, this is the place where we come show off cool stuff we're building, things that are topical right now. I think MCP has been one of those like viral things that everybody's talking about, and I think there's a gap of like truly understanding what it is, how to use it, when to apply it, and all of those things. So that's really our goal today is just to clearly explain it. We'll show a working example. As long as the demo gods allow us. But we will see. Uh, but I think the key here is understanding when to apply it, how to think about it, and what this is going to enable as we progress from here. And joined by Josue Alpizar and Omar Shanti. Omar's our CTO at HatchWorks AI. Josue is a senior solution architect, just insane developer. He does some really cool stuff. So excited for him to get to show off some of his skills today.
For folks on the
All
line,
right.
Josue is he's known as sometimes a problem solver, which is awesome. That's sort of his tagline within the company because he's just always thinking out of the box, creating and moving at an amazing pace. So really excited to share this stage with you.
I feel like I got this person like looking over my shoulder the whole time with our background image. There's somebody literally, that's my paired programmer. All right, cool. Let's get into it. So, I think we hit this quote actually last time we were talking about AI agents. And for anybody that wants to go deep on AI agents, check out our last webinar. We did this really cool demo. It was a healthcare use case around creating an agent that did a lot of insane stuff. It was within Databricks. So if you haven't seen that one, go to the website events and it's right up there. But Jensen Huang recently said AI agents are likely a multi-trillion-dollar opportunity and the age of AI agentics is here. But we got like this gap, right? There's been a ton of investment in the frontier model capabilities. We hear things about reasoning, the quality of output, and it keeps getting better. You were just, Omar, talking about the Claude 4 release and how insanely good it is reported to be. But even the best models are constrained by their isolation from data. I mean, they can leverage what they've been trained on, and then what they have access to. But building these connections a lot of times requires custom implementation, making even the most well-connected systems difficult to scale. So that's kind of our problem area that MCPs is kind of the solution to help solve that. But before we jump into that, the phone's going crazy. Uh, it's important to understand the agentic design patterns and principles, and this will set the stage for why MCP is actually important. I'm going to turn it over to Josue to kind of walk us through this aspect of things. But Josue, I'll kick it over to you.
All right. Thank you, Matt. Yeah, I think it's really important to understand what actually happens behind the scenes before we go deep into the NCP itself, because it's way easier to understand it, right? So agentic design patterns, it sounds like kind of fancy. Initially, that was my impression, but it's a pretty simple idea, as we will discover in a few when we start, resolving or trying to see what's happening in each particular pattern. So what they are trying to do is actually mimic what we do as humans. Like when we interact with, we want to resolve problems, right? So the whole idea of this pattern is to abstract the way that we think and automatically apply those patterns to the agents or to the AI. So these patterns you might be not aware of that you are currently using them. When if you go to ChatGPT or Gemini or Cloud, probably down the road, what is happening is you are using the reflection pattern or the planning pattern or the tool use pattern, and we will discuss that, how they interconnect and how NCP plays a fundamental role in the way that they interact with each other, right? So if you can go to the next
Yeah, I think
slide,
that's the
right?
interesting thing too. Like it's the systems thinking approach still applies, but there's some nuance and difference to how you deal with LLMs, agentic systems, and a lot of that.
Yeah. So the first pattern is reflection, right? Just like that word it says, is to reflect in your outputs. Like just like if you were thinking on something, probably right away you don't have the right answer. You might need to think on, okay, yeah, I have multiple paths to get to Rome, but which one is the better? Which one is cheaper? Which one is faster? So the core idea is to automate that process of giving the critical feedback to an LLM output, allowing the model to automatically criticize its own outputs and improve it. So rather than providing like one-shot answer that sometimes might be blindly, given to you, so the LLM itself kind of interacts with other LLMs or itself to reflect on that answer and provide you a better answer. So just like this visual here tries to represent, it's once you put the first prompt, it uses one output or generate one output. Then it reflects back again on the same output, trying to make it better. So imagine that if you ask for, I don't know, a calculator or something that is related to coding. So one of your requirements in the initial prompt was, I want this code to be efficient. So probably can reflect in itself, trying to find gaps like, you know what, this loop can be written in a different way, or this class might have a different name that is more meaningful to the context that it's playing with. So the LLM might be able to reflect on this in its own outputs and provide you with a better answer. And that's the whole process of rewrite the output, enhance the reflection. And sometimes it can be driven or done by the own LLM or the LLM itself, but sometimes it might use different LLMs. So throughout the process, I'll start giving some analogies, like if you were a team member working in a software company, right? So it's the same thing. Probably you'll reflect in your same outputs. The first approach for generating a new feature is not the best approach, and then you go to another team member asking for questions or asking for resolutions like, "Hey, do you see some gaps in my code? Is it a better way to do this?" And that mechanism, it is actually applied in the reflection pattern, right?
Yeah,
So
that's the beauty. You're almost adding in feedback loops throughout the process, leveraging LLMs with all the capabilities they have, which a lot, like you mentioned, they kind of mimic how humans work in a sense, which is powerful.
exactly. That particular word, the loop, is a key point to
Mhm.
understand and identify this pattern, because it is also known as the agent loop. So the whole idea is the
Yeah.
agent is looping to a point where it actually considers the answer like a good representation of the initial prompt that you entered.
Mhm.
So
Yeah.
that's very, very powerful. It's pretty simple, but so far, based on some statistics that I was watching, the reflection pattern nowadays is kind of the most used and more trust pattern that we can use.
Yeah, that's the interesting thing too. It's almost like this new scaling principle that's starting to emerge is not like the LLMs at the foundation getting better, which they are, but it's that reflective piece, which is, partly reasoning and how that works. That's also like making the LLMs better on a different vector in a sense.
Exactly.
Yeah, and one thing that we've been speaking about for a while here is sort of the advent of a decentralized architecture of LLMs, right? So rather than have single LLMs with very large parameter windows, very large sort of context windows, are you able to make more with less by arranging them together and sort of scaling them
Yeah.
horizontally as opposed to vertically, to use like a database language? We'll get more into that later on, but we talk a lot about the sort of agent mesh, and the agent mesh comes in that tradition of scaling by decreasing in complexity and increasing in sort of volume, right? So more towards that microservice architecture.
I think what's interesting too, like Claude is starting to do this. I think OpenAI is going this route too, to where you almost have one LLM that based on the query or whatever it needs to do, it can go deeper and reason, which will, expend more tokens or less. And it's kind of dynamic in a sense. And to your point, Omar, that could be across a whole family of different models where it's, you could see in the future where it's kind of dynamically determining, okay, which one do I need to use for this use case?
You are muted, Omar.
Sorry, thank you. I mean, we always speak about this world that we're gravitating towards, which is multi-turn conversations held across multiple agents, which are able to
Mhm.
communicate, delegate to each other. There's multimodal input and output as well. And because of all of this, you sort of can take advantage of multiple models as well. So it's not just multiple agents built on the same hardware, but agents that are optimized for the hardware and for the model that runs on them. So you don't need GPUs for the most mundane tasks. Instead, you could really hit that cost efficiency and not carry all of this overhead.
Yeah. All right, so hit us with the next diagram here. I think you built all these with AI too, didn't you? Wasn't
Actually, I
until
did, yeah.
yeah,
I
which
use
is
Napkin
cool.
AI.
Yeah.
So yeah, pretty cool tool, by the way. So yeah, you guys are nailing the point, because the tool use pattern is actually what drives all that communication between multiple agents, between multiple tools, right? So just like the example that Omar was provided with microservices, or the example that I provided with another team member that is an expert, like a QA expert or benchmark expert, the tool use pattern actually allows the LLMs to be aware of those external tools that they can use. So the key word in my mind for this one was functions or actions or getting data. So a LLM itself is like a sealed box that was pre-trained or trained in some data sets based on some domains. We have big models like Cloud, ChatGPT, and other these models that those companies uses behind the scenes, but they are at some point limited, trained on some specific data sets. What if you need to actually access data that happened this morning, like you wanted to create a report on a recent news, or something that just happened, like a football match that just happened, I don't know, 2 hours ago? Probably the LLM that was trained a month ago is not aware of that data. So the tool use pattern actually provides those capabilities to the LLMs to do web search, for instance, for gathering the last and latest information, right? And based on that information, provides you with a feedback. That feedback might be driven by the reflection operation, or maybe a different strategy. Here is where we start opening the multiple ways to resolve things in an agentic world. It's not that the tool use pattern is kind of coupled in a way that it only works for fetching data, because we can grab that data, reflect on that data, or plan on that data, which is another pattern that we will see, and start doing different things, right? So tool
Like
use has
Jose, if you don't mind,
yeah,
I'd just like to underscore a
sure.
point that you just made. So, what's really great about tool use is if you think about a LLM as having been trained on a corpus of data and then stopping at a certain point, then you can sort of think of them as like a fresh college grad, right? They just left, but as soon as they enter into the real world, sort of all of their information risks getting stale. And on the one hand, if you ask them a question, they can answer based on their current bank of knowledge. But as I mentioned, that risks getting stale and that's limited and so on and so forth. Or second, you can provide them the data that they need at the time that they need it in order for them to answer your question. That's, the pattern that most people associate with RAG, sort of non-agentic RAG. But then what Josue is talking about, and the premise of agents and tools, is that you can have that student, or in the real world, you can have that model tell you, here's the data that I need. I see the tools that you've made available for me, like in the same way that I can see a library catalog. I need you to empower me to go and get everything that I need in order to ask this question. And so you'll have tools for accessing the web, accessing databases, running semantic search, and so on and so forth. So think of it as empowering the model to help itself, to self-serve to the data it needs to answer your questions. Or, as Josue was saying, to take actions too.
Yeah, and that's a key, in my opinion, a key fundamental difference between RAG, or a retrieval augmented generation, and the tool use, because RAG is mostly for gathering more context for your initial prompt, right? But with tool use, RAG is just part of it, because imagine this putting actions for, I don't know, creating a new event in your calendar, or sending a new email, or even interacting with your own API. Like, imagine that you have an API that processes, I don't know, patient's data. You can put something in front of the API, and remember that's something, because that's what MCP actually does. We will discover that in a few. You can put like a layer in front of your API and make that tool available for different agents using this pattern, right? So the sky is the limit. You can actually connect whatever you wanted to, in terms of, you have to deploy what it is required to do so. But the whole idea is not only for gathering data, because remember that the better the context, the better the output, but actually providing capabilities, things that can be executed by the LLM to produce some results. Like, I don't know, you have a WhatsApp and then you receive some orders from your WhatsApp, and then you can grab the information, put that in a database, trigger in a Slack message. You get the point, right? Different workflows can be driven and done using the tool you spun. So yeah, the next one is the planning pattern, and this one is really, in my opinion, one of the most powerful but less predictable patterns. And I will say that why in a few. So the planning is actually, it utilizes another LLM, or might be the LLM itself, to decide what is the sequence of steps that needs to be done in order to execute or accomplish a big task. So imagine that you have to research about something, or you got to make sure that your actual prompt gets to the expectation that you were initially waiting on. Like, not just a single shot, please do better than reflection, do better than tool use. So in this case, this one is both like breaking down the complex objective into a smaller, more manageable subtasks. So these subtasks, guess what, can be accomplished by different agents, by different tools. So it is better and easier for the agent or the LLM itself to start assigning those tasks to the corresponding services or layers that can actually resolve those tasks. For instance, like researching for a topic that might be broken into researching multiple subtopics, synthesizing all these findings and accomplish a report, and probably reflecting on the report. Like, I wanted to make sure that this matches with this, I don't know, benchmark of the latest results that we got from the API, making sure that the code that you generated is actually going beyond these benchmarks, because I don't want to downgrade my code. Just thinking on an example, right? So this is very tangible. I don't know if you guys have used reasoning models or the reasoning capacity of the models that they provide, like Gemini or ChatGPT. When you enable that, what it does initially is actually come with a plan, right? So it tells you, like, okay, based on your prompt, these are the steps that I will perform in order to get you the actual result. And that's why people say that it's the less predictable, because sometimes the plan itself, just like a probabilistic system, is not always the same. It might differ. So in my opinion, the best way to take advantage of this pattern is to actually double check the plan. If the plan doesn't match with what you were expecting initially, then just fix the plan, right? So the better the context, the better the output.
And so, Josue, like if we were to talk about this in the context of like autonomous agents, and so team, sort of what we mean by that is we think at HatchWorks that the future of software development is changing from sort of human tasks assisted with AI to AI tasks orchestrated by humans, right? And so there's going to be this sort of shift. And one of the things that we believe will happen is the AI will be not just involved in writing software, but from A to Z through developing stories, acceptance testing, user requirements, implementing the stories, even the architecture level, and so on. So when Josue is talking here about planning, we can think of it as literally an agent that first creates the user stories that it should work on that sprint, creates the technical acceptance criteria, the architectural diagrams, the API contracts, database schemas, and so on, gets the human in the loop that Josue was mentioning, before then implementing and opening up pull requests for that human to then sort of overview. But as Josue was saying, by agreeing on the plan before you actually implement it, you can de-risk that implementation and delegate more to the agent. Is that accurate, Josue?
Exactly. Yeah, exactly. That's the whole point. And with the same example, recently GitHub released a new tool that actually creates the user stories, creates the pull request, and then left the pull request for someone to review it. So imagine orchestrating all that with planning. Like, I don't know, someone from product or business can come with a requirement, creates like a good plan that actually matches with the business requirements, and do all that automation. Like, okay, this is the user story. Using tool use, we connect to the Jira server using MCP. We will discover that in a few. And then we can create the user stories in Jira or the user stories in GitHub. And then GitHub automates the process of generating that code, creating the pull request. And you get the point, like we can extend that example to actually doing benchmarks on the pull requests, or automating the pull request creation to a Slack channel. All that is driven with reflection, tool use, and planning. That's why, in my opinion, they are very important to understand initially before we jump. And go to the next slide just to talk about the last one. This one is actually putting all these patterns together, working together. So in this case, the multi-agent collaboration overview can or explores how the agent capabilities drive us to a different implementations that actually matches with what we wanted. Like, okay, just the example that I provided, someone from her puts the requirement, and then based on that, we can generate the outputs, we can generate the plan, and different agents might be implemented differently. Like, we might have one agent trained on how to create the best user stories ever, but probably that agent is not capable of coding. So that's what the multi-agent comes to play, because the planning will say, you know what, we have to create a user story. That goes to the agent that is an expert on that part. Once they are ready, then the expert on coding will grab the user stories, and you get the idea. So these models, they can be trained in different data. They can be developed even in different technologies. This is kind of the same architecture that we use on microfrontends and microservices, right? We have a microservice written in .js, one microservice written in .NET Core, Python, whatever you wanted to. And at the end of the day, they are all together collaborating and doing something behind the scenes that seems like a single unit, like a single monolithic, right? Regardless of the way that we're reading or the patterns that they are using. Because just like I explained before, we might have different agents using different patterns or multiple patterns within the agent itself. Like maybe an agent with a tool use and reflection is a good combination.
And
So
one thing as well
yeah.
about this, and I mean this is maybe a bit of a strange session for regular attendees, because we're starting off with orienting ourselves a lot on methodology and speaking more high level than we normally do. But that's because the field is shifting so fast that unless we get a real grasp of the core concepts such as MCP, agentic architecture, multi-agent systems, then we won't be able to navigate the actual tooling conversation. So although this is a little bit different from our normal content, please lean in, because this is incredibly valuable stuff, and just really helps set you all up to ride the waves that are due to come in the next months and years.
Yeah. Yeah, and all this, like the foundational knowledge, I mean, we can go even deeper because there is a bunch of things that we didn't explore about each pattern, but it's just for the audience to get the idea of, okay, if I am prompting something to ChatGPT, what is actually happening behind the scenes, how ChatGPT do the web search, for instance. And that leads me to the next slide, which is, okay, the same example that I just provided, the microservice, right? We might have multiple microservices in different tech stacks or different clouds, but they can't connect each other. How they do so? They actually use a protocol. They use a single language, a single way to communicate, regardless in the way that they were reading before. We might have Node.js microservice with Python microservices, and we can exchange data between each other. For one is a domain expert on the orders, and the other one is a domain expert in the invoicing, right? And they have different architectures, even different databases, but they can communicate using different protocols, HTTP or REST APIs. So at the end of the day, that's what a protocol is. It's just a standard way to communicate one point, let's call it point A to point B. And they define the rules, they define the way to do it. But the protocol itself, it's not like the channel that we use to communicate. It happens, different things happen here, but the protocol is the idea, like the contract that we should follow. Go to the next slide. And guess what? This is where MCP comes to the equation. So regardless of the pattern on the way that you design or you architecture your agent, they communicate using MCP, or that's what we are, trying to elaborate with this visual here. So regardless of what you put in your ecosystem, the whole ecosystem with a bunch of agents can communicate between each other using a single language, a single way to exchange in data that is actually understandable by the producer and the consumer. Go to the next one. So now going to the real point, what is the MCP model, or Model Context Protocol? That's what it stands for. It was originally developed by Anthropic, which is the creators of this big model cloud. And it's just that, it's the new open standard protocol, the way, the channel, the bridge, that all we should speak in the same language so we can intercommunicate our agents with my agents as, I don't know, company A with company C, B, and C. It really doesn't matter in the way that we develop that, we can communicate in the same language, right? So
That's the beauty. It's actually gotten a lot of adoption because a
exactly.
new protocol without adoption and kind of people centralizing around it just becomes another protocol. But that's been the unique thing, I think, with MCP is its adoption has been massive when it comes to agentic systems.
Yeah. A while ago, I remember that initially we had SOAP services. They were a mess, so to say. And then someone came with the idea to develop REST APIs, and then we have like 2 languages. And sometimes we ended up like not being able to connect to some services simply because I didn't develop my service to interact with SOAP, but with REST. So this is now the opportunity that Anthropic is providing us for breaking that bridge of not having multiple ways to communicate, but a single way to do so. And the protocol itself has some, components that makes this thing a reality. And they are pretty much the server. The server is I call it like a layer sit on top of your APIs. That's what I think the best way to understand it. Like, imagine that you have already an API, you have an application that, exposes some endpoint that either your front end or integrations can consume. The MCP server is actually a layer that you sit on top of your API that will communicate to the client, the MCP client. So the server is a lightweight adapter. Typically, is lightweight. Is just like a bridge to saying that this concept of a load balancer also applies here. Like I get a request and I route this request to different endpoints based on what ask, and it exposes the application's functionality that might be written in multiple ways, multiple tech stacks in a standardized way. That's the key point. So the server acts like a translator, so to say, from your app. So we have an MCP server in front of Google Calendar, an MCP server in front of Slack, an MCP server in front of my API that talks to the MCP client. So the client itself is what the model uses to invoke those MCP servers. Because the model typically is not aware of how to consume the server, but the MCP client does. And what the MCP client, once it gets the information back from the server, it translates that or provide that output, again, context, to the model so the model can react to that context based on, I execute some function, I created some Google Calendar event, and based on that, do something with the patterns that we just saw. And
it's all about context.
What's that?
I said it's all about context.
It's all about context.
With so many things, yeah.
Mm-hmm. So the MCP server protocol is just that. That's the language, but it involves like all these components, and all these kind of components working together is actually what makes MCP a real thing. And the services, lastly, is just the actual apps, databases like your, I don't know, VS Code when you use Copilot, or what was the other one? Cursor, when it invokes different models, when it invokes different things to a web search and all that.
And I'd like maybe just to underscore, or just to say it slightly differently, which is Folks, the MCP provides one single standard, one single protocol, right? And it's been adopted. And the currency of any standard is its adoption. The standard that's not adopted is just like a theoretical framework that no one uses. I love to give the example of the United Nations because I think that this sort of makes sense in that context. Countries and ambassadors that attend the United Nations are surrounded by folks from at least 100 other countries. Rather than each person needing to learn how to translate their language into all other 100 languages, they all just know how to translate their language into English, right? And so rather than this N by N integration nightmare, you have a one to N sort of translation integration. With MCP, it's kind of similar. So rather than need your LLM to understand the Salesforce API, your microservices, your database, it doesn't need to understand SQL, etc. You can just sort of have it speak one language, your MCP language. And what's so powerful about that is now your context window is freed because you don't need to upload this massive documentation and have your model sort of parse through it every single time. You're saving so much cost, you're unlocking so much more possibility, and you're actually reducing the barrier to entry for other people to reuse. So it's well and good for you to upload this whole product manual into one model. But let's say that now you've got like 12 or 13 different agents that you're building. Well, you've got to do that every single time, and you've got to make sure that they're all in sync. So not only is it a upfront hassle, but it's an ongoing cost and it risks getting stale. Hence, MCP, by allowing everything to be translated into one language and being solved once, just makes it far easier to get the bang out of your buck when it comes to your data and your context.
And this is completely off topic, but I don't know if you saw Google I/O, their conference. They're doing like this real-time language translation now, which I guess you could apply that as like a meta thing. Um, but it's just insane what is going on right now. And I know that was just an analogy, but
No,
imagine
I
how
mean,
cool that's going to be when you're,
yeah, I mean, imagine like a real-time HTTP to MCP, you know, like that
yeah.
would be sort of the analog over here, where obviously MCP is built on HTTP, it's built on these protocols. It's just sort of an abstraction like REST is. If
Mhm.
those words don't really make sense, don't worry about it. But the translation is a core part of this.
Yeah.
Yeah, exactly. That, and just to elaborate a little bit better on that, maybe in the technical part, the way that they communicate is actually protocol or transport agnostic, meaning that we can communicate an LLM with another, sorry, an agent with another tool or another agent or another LLM itself using MCP by HTTP, WebSockets, standard IO. So it's really kind of, not coupled to just use HTTP regular requests, because we can actually go with WebSockets or more live connections. So yeah, just
And I think
is,
here, just like to sum it up, like,
yeah, exactly.
with LLMs are great by themselves. Like they're really cool. Once you give them access to tools, plus a little bit of orchestration, now you're getting into this agentic nature that Josue has been talking about. But the thing that MCP enables is you can then scale what you're building via these agentic systems and approach. Like that's the big unlock is you can scale these things in a manageable way at the end of the day.
Yeah, exactly. And just I think just to elaborate a little bit better, the last part of this visual here, where NCP comes to the play, is like it's more than just tools. Remember the tool use pattern? It's actually connecting your LLM to a whole ecosystem or another agent that might be written or designed in a way that it uses reflection, tool use, multi-agent mirror. So NCP is just a connection between everything, and you can create ecosystems as huge or big as you want it to, all speaking the same language.
I think the last thing here, the Google said their A2A protocol, which is like this other standard coming out. But Josue or Omar, when do y'all want to hit on this before we jump to the demo and kind of how that fits in with MCP?
Yeah, sure. So I think maybe it's worth talking about what an agent is versus what a tool is. Um, you can think of an agent as sort of a bucket, a wrapper, right? That includes a few different things. There's the LLM, there is the prompt or series of prompts which give guidance to the LLM. There are the data sources and functionalities that it can perform, which are known as tools. These are called tools. And maybe one or two other things like your orchestration engine and your monitoring and alerting and monitoring and observability. So ultimately, that's what an agent is. It's a wrapper that points to tools and it points to LLMs. So it uses these things. They technically don't live within it, but an agent is attached to a LLM and to a set of tools. So the reason I mentioned that is agents and tools are different things. The agent-to-agent protocol makes it far easier for one agent to interact with another agent and delegate tasks, right? The MCP protocol is different because it enables tools to be published a lot more seamlessly. So whereas A2A enables agent-to-agent communication, it aims to standardize it. MCP MCP standardizes agent to tool communication, right? Agent to software communication. So as you can see over here, they coexist. They just solve for different connectivity points.
Awesome. And I think there's tons of like repositories out there where you can now get these MCPs and connect to them. A great one's Cursor Directory. I'll drop the link in the chat, but there's just tons of, you see like Google Ads, Google Drive, Stripes in here, Docker, Figma, Postgres, Snowflake. There's just tons of these out there, just making it easy to connect and whatnot. All right, Omar, you want me to keep this up and then let you take over share, or do you want to go ahead and take it over now?
No, keep it up for a sec. Let's take a second to answer the questions on the line here.
Oh yeah, good call. Yep. Yeah, so we got one from Griff saying if MCP was developed by Anthropic, how extensively is it used across the AI world? I assume OpenAI, Google, Microsoft have their own similar protocols. This is what's interesting about this, and I think somebody already, Harsh put in the comments that Google in their huge I/O conference this week, they actually talked about MCP and adoption there. So this is a unique one. I'm curious, Omar or Josue, but like it's getting like more universal adoption. Even like OpenAI's talked about it, integrating it,
Beyond, yeah,
leveraging it.
right,
Yeah.
beyond that. So 6 months ago, and literally, so I actually pulled up my newsletter here. If anyone's not aware, we have a newsletter at HatchWorks. We deliver sort of like the latest and greatest in the world of AI. So subscribe if you're not already, so that you'll learn about MCP 6 months before, 6 months before everyone else is talking about it. But in that newsletter, I was talking about how MCP is building on sort of the dying embers of ChatGPT's exploration with its plugins module. And the whole notion of this plugins module was enabling the self-publication of tools behind a single framework. For too many reasons to get into here, it sort of failed. It wasn't adopted by the community and it wasn't scalable. It wasn't sort of built with the right abstractions. And a lot of lessons were gleaned by the folks at Anthropic, who then put forward this model context protocol. Within weeks, I don't even think months, OpenAI announced support for the model context protocol. And in doing that, they sort of endorsed it. It was a time when sort of the space came together to officially endorse this context, give it a lot more currency, which, as I mentioned, is the crucial thing when it comes to a standard. And so, yes, there's a lot of collaboration, and I think this is just going to be this is not going to go anywhere anytime soon. This is a safe bet to make it. This ecosystem, it's tried and tested, and it's been around for ages. The other complexity is not so much in adoption as much as in things like authentication and doing it the correct way. We can get more into that if folks have any FAQs, but one of our longtime collaborators at Featureform just created a really awesome sort of MCP engine published on AWS that solves for MCP in an authenticated way based on conversations around its authentication and so on. So we'll get more into that later on if needed.
Cool. And there's Jeff also said there's lots of work to be done building MCP servers. Well, I guess this is a question. Building MCP servers across an enterprise infrastructure. So the work, this may be a segue into the actual um, use case here as well, Omar. We're just talking
Yeah,
about the
and so
work involved in actually building these out.
yeah, I'll frame that by saying, ultimately MCPs enable data and action, and there's always data work to be done in enterprises. MCP is one route forward, but a lot of the times organizations actually shouldn't start with doing MCP work, but instead start with doing like data foundation work. So if they're looking to unlock analytics and unlock sort of larger questions, then rather than just tack on an MCP server, they ought to invest in building, a real great data pipelining practice to bring data to their data warehouse, take it through their medallion architecture, and publish it. But you're spot on in calling out that there's a big gap right now, and MCP can fill that gap. And let's make this real. Let's talk about a fictional company called GlideCare. So GlideCare is effectively a healthcare operations company that's sort of centered in physiotherapy, physical therapy, right? So in patient recovery over muscular injuries that involves physical therapy and a number of patient-doctor touch points. So very white glove business, very centered on patient outcomes. However, GlideCare has grown a lot by acquisition, and they're in a highly regulated space, so their data landscape is scattered. They have a few different products that they've acquired. One product allows patients to input day by day how their pain is going, right? Are they feeling more flexible, more limber, and so on. But that is one system that doesn't fully communicate with the other systems. For example, another acquisition that they purchased at the height of IoT is a wearable metrics company. And this company is a watch that, as you wear it, emits data around your movement, around your activity, and so on. Just to sort of give a sense to your physicians around whether you're following up on your medicine, whether you're following up on your prescriptions and so on. And then lastly, PhysioNote. So touch points from every time that you go and see your physical therapist. The issue is, as I mentioned, they're all in different systems, and these systems weren't built sort of to assist in interpreting data as much as in collecting that data. So it's fairly difficult to do suboptimal outcome. It leads to suboptimal outcomes because it's fairly difficult to do that raw data analysis for a time-sensitive resource like a physician who's balancing a lot of things. And the context can be stale, right? Because you're not getting that patient 24/7 view. So what is the solution? Well, by sort of bringing together the context from all three of these systems, the pain logs, the wearable metrics, and the physio notes, the real-time data, not the analytical data, but sort of the real-time data that's stored in their transactional system, through model context protocol, embedding that into your LLM, you can enable quicker action so that you can enable better patient care, you can enable more personalized touch points, and more physician oversight. The MCP plays here nicely because it's a nightmare to build these system integrations, right? Because each of these systems, to use the UN example, speaks a different language. So rather than sort of take English, Arabic, and Mandarin, you can sort of teach your LLM just to speak the one language that all of those translate into, which is sort of the MCP protocol language. So on the next slide, we'll just take a look at the high-level architecture over here. Actually, no, we'll start off with the personas, I suppose. You've got Alan, the patient, Sophia, the nurse, Dr. Tasabaji, the family doctor, and then James, the insurance officer. In the interest of time, I won't stay too long, but just to highlight there, if we go back there, Matt, all four of those have a different sort of set of data requirements, a different clearance level, a different relationship to the data, and sort of different technical aptitudes. So this sort of white glove personalization approach, it needs to ensure compliance as well as sort of a bespoke user experience for all four of these distinct personas. So on the next slide, we'll see the architecture. And I've only called out two of them for today's demo. We've got the patient and we've got the physio. The patient's got these two systems, as I mentioned, the patient logging system. We'll take a look at it, but it's a single page app. And then as they log in, there's an API in the database. So very standard client server architecture, but add in the regulations, the authentication, the different cases, and it becomes a little bit more hefty. The patient wearable systems, which collects data transmitted from their device, ingests that into a database. And then lastly, you have the physical therapist's reporting system, which they use for all of these in-person touch points with the patient, with a different API and a different database. And imagine all of these, as I mentioned, have grown by acquisition. So not only are they just sort of different databases, but they're on different clouds. One of them is on premise, another is on a sort of hybrid cloud setup, and the third one is sort of like this ad hoc vendor managed cloud. So super siloed. How do you start unlocking value? Well, one way in is MCP. It's not sort of the gold standard when it comes to actually doing data transformation work, but it helps you unlock insights from your databases, from your SaaS systems almost right away. And so that MCP can either be stacked one by one, or it can sort of have like this more integrated layer, which can fuse data from these different systems to enable your AI layer. So self-serve patient care, physician view, near real-time adjustments of treatment plans, and you can even automate rescheduling just to make everything as smooth and seamless as possible. And I suppose with that, I can dive into the demo here. And as with all demos, we're gonna just hope that the demo gods collaborate and also sort of accept if they don't, because that's sort of the nature of live demos. But either way, so let me just do a little bit of setup here. Okay, perfect. So as we saw, there's quite a big digital landscape over there, right? There's 3 different client server applications, and there's the MCP servers as well to add on. So I'm going to give us just a quick tour of what my setup is here from a coding perspective. But because we're not primarily a technical audience, we'll sort of gloss through that and keep it moving. All right, wonderful. So sharing my screen here, what we can see first is I've got, let me go to my terminal. What we can see here is I've got, I've got 3 basic buckets. I've got the patient logging application, the physio notes, and the wearable metrics. We're looking at my terminal. It looks like the matrix, but there's nothing to be too worried about. We'll start off with the patient logging experience. So the patient logging effectively looks like this. It's a standard pain log app, super simple. Physician logs in. They select the condition that they are sort of logging today, because it's entirely feasible. A physician has multiple. They select the pain level that associates with that, add some notes, and I can say, I just drove for like 3 hours to get 15 miles in California. Sort of a true story. Traffic is terrible there. So I'm going to log that. It's there. On the back end, we're persisting it to our database, which is it's neat. That's sort of one application, the pain logging. But then you've also got sort of the physician session notes over here, which is the second bit. Over here, I can just add in sort of an observation as a physician, a recommendation, or an escalation to do with my patient, who is loosely based on me, I suppose, and who has lower back pain, who is actually very much based on me. So, this patient
I was about to
is
say,
a
you're solving your
whiny
own problem here, I
baby.
think. Omar.
Sorry. Now making it really based on me. This patient is a whiny baby who complains too much. That's my observation as a physician. So that's been saved. That's been written to the back end. Well and good. I can also, sort of add recommendations or escalations if I wanted to get in touch with either the physician, the insurance provider, or a recommendation to go directly to the patient. Both of these have got this neat AI assistant where, a patient can sort of ask questions. So how can I help you with your lower back pain today? I can say, it's just excruciating. I'm all seized up. And, this is going to sort of like imitate a actual flow. We haven't built in, for the sake of this demo, the actual sort of prompt, just, cutting out scope for the demo because it's not directly useful to us right now. But imagine that MCP touchpoint eventually making its way here. And the same with the OpenAI assistant over here. I can say summarize this person's last 3 sessions, and we'll get some insights. Again, imagine more of a white glove experience based on a holistic picture of the data rather than only the data that's loaded into the AI assistant. So those are 2 data sources. The third data source is the wearable technology. I don't have an actual demo for it because it's a wearable technology, right? But I do have within my wearable metrics folder over here, I have a patient logging. No, I have a wearable metrics I don't know, wearable metrics database somewhere here. I think this is it here. Yeah, the wearable metrics database, which is just constantly getting written to by this wearable metrics app in order, it's actually it's exited, so it's not running now, but effectively being written to by this wearable metrics app in order to imitate sort of real life data touch points. All right, so this is well and good. We've got all of this data, but it's still siloed and we haven't seen anything from MCP. Well, one thing I do want to show is what an MCP server will look like. So over here, I've got a very simple MCP server. It's written in Node. And without boring anyone with the code, I'm just going to sort of call out that what this does is, sorry, let me just move this around. What this does is expose a individual tool for our models, any model to use, called GlideCare Wearables Latest, which is going to get the latest metrics for a patient. And it's effectively going to execute a SQL query on our behalf. It's going to parse the results and then give it to the end user in a way that makes sense. And this is actually hitting our database. So it's fully integrated to the sort of database that we just seen. So well and good, we've got this tool. How do we actually use it and where do we use it? Well, the plan is to use it over here, right? The plan is to sort of take this tool and bring it to our end users, our insurance provider, our physician, put the data in their hands. But one thing that's pretty neat is you're not just restricted to this, because I can go to even Claude Desktop, like something as strange as Claude Desktop, right? And I can list it as a tool here by doing File, Settings, Developer, and Edit Config. I don't know if you can still see this, but anyways, this will open my Claude Desktop config over here, and I can see that I can list MCP service as Josue was showing for the weather. For Playwright, we actually use this to write automated tests so that our clients get sort of better outcomes. GitHub, and then this new one that I just created, which is sort of that wearable metrics, check the latest metrics. So that's pretty cool. And then over here, if I click on searches, what's this called? Search and tools, I can see also that we've got this check metrics thing over here for GlideCare wearables latest, and it is enabled. So I can ask it, hey, give me the latest status for, what is it, Omar 2847, for the patient Omar 2847. And behind the scenes, the Claude Sonnet 4 model is going to look at the tools that it has access to. It's going to recognize from the metadata that this is the best tool to use. It's going to formulate a request. In this case, the request is so straightforward, just Omar 2847. On the back end, the MCP server is going to execute that query that we just saw, which is like pretty hefty, pretty ugly. And then it's going to give us this response. Claude's then going to take that response and it's going to actually give us sort of the data that we need. And again, I'm using Claude Desktop as the interface, but it's totally agnostic to the interface. All this is going on behind the scenes. So I could have just as easily used this AI assistant, this code chat, a phone gateway, or a text system, if not like an integration with your sort of your underlying system too. While we're here, I think it's also worth just hinting briefly at the fact that you can also use these servers that exist on sort of the MCP server directories on the MCP GitHub and so on. One example is this, here we go, Claude Desktop, is this weather. So effectively all this, let's look at this weather. Effectively what this weather MCP server does is just hit a weather API to get the weather. But if I were to ask it, hey, what's the forecast for New York on Tuesday? Again, it'll do the exact same process of assessing its tools, figuring out that get forecast is the right one to run, hitting a latitude and longitude endpoint to get data, and then sending it in order to get this temperature. We can then lace tools together. I can have a tool that will sort of go and create an outfit for me based on my wardrobe, another one that can create activities for me based on like a TripAdvisor or one of those sort of platforms. And by chaining these tools together, which MCP makes really easy to do, you can start building some really exciting workflows. And with that, I'll stop. We can get to any questions folks have.
Awesome. Yeah, good stuff here, Omar. Yeah, if anybody has any questions, drop them in the chat. I'll also while we're waiting for anybody to have any questions,
Yeah,
just show
Jeff,
this
Jeff
really
had one.
quick.
In this case, Cloud Desktop is an MCP client. That's exactly right, Jeff. It's an MCP client, and what's really neat about it is it runs on desktop, so you can automate a lot of your workflows and extend it through the use of MCP so that it can automate everything from like your shopping in the morning to getting news feeds for you to whatever it is.
Yep, and just a couple resources. We got our State of AI report. It's been out there for a bit now for this year. The podcast, I think Omar mentioned the newsletter earlier, and then obviously these labs we do. Two things to note. So, yeah, all of this kind of ties into our approach to building with AI. We call it generative driven development. So we've put together this guide. This gives kind of a high level overview of the methodology. So snag that, download it. Andy, if we can drop that in the chat too. And then we have an offer as well. If anybody's interested in going deeper in we do these training workshops for GenDD, so kind of tailored to engineering teams, teaching them how to build with AI, MCP being a component of that. We're doing, I believe it's 5 of these by the end of the quarter. So we got spots for 5. So if you're interested in that, I think the link is in the chat if you want to grab one of those slots. Really just helping the adoption of using AI throughout the development process. All right, any more questions? Right at about time. Let's see if we got any other ones. All right. We got Harsh. The beauty is that the LLM model infers users' intentions and makes the tool call, taking away the pain of inferring the user's intention. Yeah, so that's like this whole new capability that LLMs are enabling in a sense, uh, which just it opens up so many different opportunities of things you can build in new and novel ways. It reminds me back when kind of the mobile movement happened and what that enabled. Now that everybody had a smartphone in their hand, it's just this new approach to doing things. All right, any other questions before we wrap it?
Yeah, curious. Are folks already
Yeah.
using MCP? Have folks begun experimenting with some of um, the open source ones on the marketplaces? Love to get a feel for where everyone's at in their journey.
Yeah, drop it in the comments. Yeah. See if others have started to play around with it. I think everybody's heard about it. I think that's the gap trying to start using it now. All right, we got a super cool demo. Love the content from Josue as well. Appreciate that. And if y'all got questions too on the MCP side of things, please don't hesitate to reach out. We can go deeper there. All right. I think we can call it there, guys. Appreciate Omar Josue, y'all presenting today. Great stuff. We'll put the recording out there in case you want to share it with others or if you weren't able to catch it all. And we'll call it a wrap there. Thanks, everybody.
Thank you, everyone.
See you. Bye bye.